Welcome to this episode in the 3D visualization series of tutorials and guides in an ongoing 3D Technologies program. I'm your host, Aaron Ellis. In this video, we will learn about the tools and processes involved in setting up 3D scenes. We will also learn how to set up simple materials and textures for objects in a scene. With those introductions out of the way, let's get started. Let's begin by discussing the Cartesian coordinate system. The Cartesian coordinate system outlines the three axes that define all three-dimensional worlds: the x-axis, the z-axis, and the y-axis. The x-axis is typically represented by an infinite red line. It has both positive and negative coordinates. Similarly, the y-axis is represented by an infinite green line with both positive and negative coordinates. And finally, the z-axis is typically depicted with an infinite blue line with both positive and negative coordinates. Blender 3D typically does not show the z-axis, but I've enabled it here. The intersection of the x, y, and z axes is known as world center. There are many types of objects in a 3D scene. Blender typically starts with three such objects: a cube, a camera, and a light source. Various 3D objects can be identified in multiple locations in the Blender interface. Shown here are some additional 3D scene objects. In addition to the starting cube, we also have the circle, the plane, the UV sphere, the icosphere, the cylinder, the cone, the torus, and Blender's mascot, Suzanne the monkey. And if you have the ANT landscape add-on installed and enabled in your Blender software, that object type will be available also. I mentioned earlier that the Blender startup screen includes a camera and a light source by default, along with the starting cube. There are several types of lighting objects. Of the various lighting types, we have the pinpoint, the sunlight, the spotlight, and the area light. But we'll look at those in more detail later. Another object type that we can use is the text object. Text objects can be edited to say almost anything. In addition to these elements, we also have the 3D cursor. Blender's 3D cursor is unique among 3D development software. It serves the same purpose as an insertion point in a word processing program. Finally, on my screen, you will notice a small widget in the bottom center of the 3D viewport. This element represents a Screencast Keys add-on to Blender. This tool echoes and displays keyboard and mouse inputs. It is used to help make learning Blender a little bit easier. Another important element for scene setup is the 3D viewport menu. This is different from the main Blender menu, and it only offers 5 sections of options. The first of these is the Mode Selection drop-down box in the upper left corner. This allows users to switch from Object Mode to Edit Mode to Sculpt Mode, and then on to various painting options. For this lesson, we will mostly remain in Object Mode with some minor work in Edit Mode for text objects. Sculpt Mode will be saved for the future 3D sculpting lesson and video. After the Mode control, the Viewport menu also features the View, Select, Add, and Object menu options. These allow for a variety of functions. The View menu heading allows for the hiding and showing of toolbars, the focusing on selected objects, switching viewport angles, and more. The Select menu provides multiple ways to select and deselect world elements, including by type and proximity, and also the ability to select objects at random. The Add menu is where new scene elements are dropped into the virtual world at the current location of the 3D cursor. Options for adding planes, cubes, circles, spheres, cylinders, cones, tori, landscapes, text, lights, cameras, and even more exotic objects are also available. Again, these new additions to the scene will show up wherever the 3D cursor is positioned. Sometimes that means objects will start out on top of or inside the geometry of other elements. Later, we will learn how to change the position of the 3D cursor to add new objects where we want them from the very start. The last viewport menu option is Object. This is where we will find menu-based tools for transforming selected objects by moving them, rotating them, or scaling those objects. These functions can be more precisely performed using other methods that we will discuss in a few minutes. There are other very useful tools inside of the Object menu, but we won't use many of these until future lessons. Most of these options will be especially helpful during our upcoming 3D modeling lesson and video. But for now, one of the most important of these additional features is the Apply menu option. This allows us to reorient an object's default sense of its own position, rotation, and scale within a Blender scene. This may not make much sense right now, but trust me, it makes a big difference in how objects, modeling, and texturing operate. Additionally, the Duplicate Object, Copy and Paste, Parent, Collections, and Relations options, along with Shade Smooth and Flat, and a handful of quick effects, can also be very useful. Now that we've got a feel for the viewport menu options, let's use the Add menu to place new objects into our scene. But first, let's select all of the current objects with the A key on our keyboard, followed by the X key or the Delete key to remove them. The first object added here is a cylinder. Notice that a collapsed Add Cylinder Initial Settings panel appears in the lower left corner of the viewport. I can delete the cylinder object by pressing the X key on my keyboard and confirming its removal. After that, I can add a new object to the scene, in this case a cone. Also, by clicking the triangle to the left of the collapsed Add Cone Initial Settings panel, it can be expanded so that its options can be adjusted for the number of vertices that it has, its lower radius, its upper radius, its depth, its location in the X, Y, and Z axes, and its rotation along those same axes. After these initial settings have been made, we can collapse and expand the panel by left-clicking the triangle to the left of its title. However, if at any time we accidentally select any other object in the scene or deselect the object we just added, then the initial settings panel will disappear. By selecting other objects, Blender assumes that we are finished editing the current element. If this happens, sometimes it's best to delete the object and add a new one of the same type. Thankfully, Blender will remember the settings that you made just before losing the initial settings panel. It's a minor annoyance, but it's easy to fix. Just make sure that you finish editing the initial settings for any new object before you select any other objects in your scene. Next, let's focus on how we can select objects in Blender. Typically, the easiest way to select something in the viewport is to left-click it with a 3-button mouse. However, we will need to make sure that we are in select mode first. This can be found at the top of our toolbar. Selecting additional objects can be accomplished by holding down the Shift key on the keyboard while left-clicking Additional Objects. Selecting objects can also be accomplished by left-clicking Entries in the Outliner panel in the upper right corner of the Blender 3D window. Additional objects can be selected from the outliner by holding down the Control key on the keyboard while left-clicking Entries in the Outliner panel. Also, the Shift key can be used when left-clicking Entries in the Outliner panel to select multiple objects within a range. Now let's take a look at one way to manipulate the location, rotation, and scale of existing 3D objects. To do this, we will need to use the toolbar. By switching from the Select Box mode to the Move mode, and then clicking and dragging an associated axis arrow, we can move the object around our scene. The X, Y, and Z axis arrows lock movement into one axis only. If we want to move an object in two axes while ignoring the other axis, we can do this by left-clicking and dragging one of the red, green, and blue axis rectangles. By activating the Rotate tool on the toolbar, we can change the rotation of our object in the X, Y, and Z axes, but also on the axis that corresponds to the flat panel of our display. Scaling an object works almost the same way. We simply left-click and drag the red, green, and blue boxes which correspond to the X, Y, and Z axes. To achieve even more precision in the moving, rotating, and scaling of objects in our scene, we can use the Sidebar panel. After we've expanded the sidebar, we can find the Location section with its X, Y, and Z parameters, followed by the Rotation section and the Scale section. The values of these parameters can be adjusted by left-clicking and dragging left and right, or by left-clicking the left and right arrows to either side of the parameter, or by typing in a specific value. This approach works for location, rotation, and scale. It is possible to change multiple parameters in a section block by left-clicking and dragging down, by typing in, or sliding for a new value. In addition to using the transform operations found in the Object menu and the toolbar and the sidebar, it is also possible to move, rotate, and scale scene elements using keyboard shortcut combinations. To initiate a move operation, press the G key on the keyboard and move the mouse around. Once this has been done, it is possible to lock the new location of this object by left-clicking the mouse or by pressing the Enter key on the keyboard. It is also possible to constrain movement in one axis or another by following the G key press with either an X, Y, or Z key press corresponding with those axes. It is even possible to contra-constrain movement in one axis by following the G key press with the Shift and X, Y, or Z keyboard combination. As demonstrated earlier, contra-constrained movements lock translation, rotation, and scaling activity to two axes while ignoring the other. Precision object placement can be accomplished by following the G key press and the axis constraint key press, which is X, Y, or Z, with a numeric input. For example, after selecting an object, someone could press the G followed by the Z and then -2 to move the selected object down in the Z axis by 2 units. Object rotation using keyboard shortcuts is also possible and can be initiated by pressing the R key on the keyboard. Doing this will allow the rotation of the selected object on a subjective axis that corresponds to the current viewport angle as the mouse is moved. However, to use free rotation in all 3 axes with accompanying mouse movement, it is necessary to press the R key again. Viewport axis and free axis rotation can then be toggled back and forth with additional presses of the R key. As with the translation or move keyboard method, the rotation shortcut can be constrained to one axis or another by following the R key press with either X, Y, or Z on the keyboard to correspond with one of those axes. And contra-constrained rotation can be enabled by holding the Shift key while pressing the axis keys. Precision object rotation can be achieved from the keyboard by following the R key press and the axis constraint key press, which is X, Y, or Z, with a numeric entry. For example, it is possible to rotate a currently selected object in the X-axis to 43 degrees by typing the keystroke sequence R, X, 43. Object scaling using keyboard shortcuts follows many of these same conventions and can be initiated by pressing the S key on the keyboard for the currently selected object and then moving the mouse. Constraining object scaling from the keyboard can be accomplished by following the S keystroke with either the X, Y, or Z keys that correspond to those axes. As before, Contra constraint is also possible by accompanying the axis keystroke with the Shift key press. Finally, precision object scaling from keyboard combinations is possible by following the S key press and the axis key press with a numeric entry. For example, to scale a selected object in the y-axis by 2.3, simply type S, Y, and 2.3. Over the past few minutes, I have demonstrated just 4 ways to move, rotate, and scale objects within a Blender scene. But believe it or not, there are even more ways to do the same things in Blender. These other methods won't be covered in this lesson, as they are less accessible and a bit more confusing. Next, let's take a look at the Outliner panel. Blender uses a hierarchical structure system composed of collections, which are similar to folders, and also objects. Objects can be moved from one collection to another by left-clicking and dragging them from one location in the outliner to another. These objects can even be moved from inside of a collection to the general area outside of any and all collections. Collection folders can be collapsed and expanded by left-clicking the small triangle to the left of each. All entries in the Blender Outliner panel can be renamed by left double-clicking them, and then typing in a new name. Finally, collection contents and individual objects can be hidden or shown in the viewport display by left-clicking the eye icon to the right of each and then left-clicking it again. However, please note that objects hidden in the viewport are not really gone. They will still show up in external image or video renders. Next, let's take a look at the Properties panel. This topic is so massive, it really deserves a training video wholly dedicated to it. However, what follows will be a very brief discussion of a very complex subject. The Properties panel can be found in the lower right corner of the Blender window. Here we can find many options hidden within several tabs with colorized icons. Typically, there are 14 of these tabs visible, but the visibility of the tabs in the Properties panel is entirely dependent on the currently selected object or objects, if any. We will only focus on a handful of these for now. The first item in the Properties panel is the Active Tool and Workspace tab. The icon for this tab resembles a screwdriver next to a wrench. This tab will be very important during the upcoming 3D sculpting lesson, but it will not be used for the visualization discipline, so let's skip ahead. Next is the Render Properties tab. This section starts with a Render Engine option, which by default is set to the Eevee PBR Real-Time Rendering Engine. Cycles and Workbench engines are also available in stock Blender. But for this lesson, we will stick with the Eevee Real-Time Renderer. In addition to the Render Engine choice, the Render Properties tab also includes parameters for setting render and viewport samples, which help determine image quality. It also includes options for ambient occlusion, which simulate shadows in corners, bloom, which fakes the effect of glare from bright lights, reflection and refraction for shiny and transparent objects, volumetric or atmospheric effects, shadow quality, and color management. None of the settings in this panel will be noticeable in wireframe or solid rendering modes. These settings will only show up in Materials Preview and Rendered modes. After that is the Output Properties tab. This area includes options for determining the resolution of rendered images and videos, but also the starting and ending frame numbers for animations and videos. It includes settings for the video playback frame rate for animations, where film speeds are typically around 24 frames per second, and American television speeds are often 30 frames per second. The Output Properties tab is also where rendered image output folders, file types, encoding options, and audio settings can be adjusted. If we skip down to the World Properties tab, we see options for universal background and lighting, as well as universal atmospheric or volumetric effects. While the sections here look very limited, this is one of the most expansive tabs on the Properties panel, as it has hundreds of buried settings. Some of the settings on the World Properties tab are dependent on other settings in the Render Properties tab. The next section to discuss is the Modifier Properties tab. Again, this looks very bare, but this tab is also deceptive, as many geometric functions can be added and stacked onto any selected object in a Blender scene. The discussion of the majority of these options will be saved for the later 3D modeling discipline lesson and video. Next is the Physics Properties tab. This allows for the animated simulation of water, smoke, fire, explosions, cloth, and traditional gravity and bounce physics. The options from this tab will be covered briefly in the third 3D visualization video lesson, which will discuss animation and motion effects. Next, we have the Material Properties tab. This is where scene objects can be assigned colors, patterns, transparency, and other surface effects like roughness, metalness, and specularity. The next three tabs are often hidden from the Properties panel, except when special object types are selected. Technically, all of them are labeled Object Data Properties, but I will refer to them here by their functions. The first of these is the Text Properties tab. This is where settings for text objects are adjusted. Font selection, extrusion, beveling, alignment, spacing, positioning, and sizing can all be changed in this tab. This tab is only visible on the Properties panel when a text object is selected. Next is the Light Properties tab. This is where various light source types are selected, as well as light color, light strength, shadow casting, and other properties are adjusted. This tab is only visible on the Properties panel when a lighting object is selected. Finally, we have the Camera Properties tab. From here, users can change the type of lens used, its focal length, clipping ranges, depth of field for controlling zones of focus, background images, and more. As before, this tab is only visible in the Properties panel when a special object, in this case, a camera object, is currently selected. That's it for this lesson, and let me know if you have any questions about this or other lessons.